Good morning, I am Renu Sharma, Assistant Professor EC Department from the college, that is Ajay Kumar Kark Engineering College, and the topic of today's lecture is Internet security. These are the contents of today's lecture. First one is Internet protocol security, that is in short it is known as IPSEC. Then TCP/IP protocol suite that is transmission control protocol, Internet protocol, IPv4 and IPv6. Then firewall. So, these three topics are related to internet security. Whenever we are using internet, whenever we are transferring information over internet, then security is very important, otherwise the virus will going to affect our system or affect the information that we have transmitted. So, this is the first one, that is IP security or IPSEC. It is a collection of protocols designed by the Internet Engineering Task Force IETF to provide security for a packet at the network level. So, what is packet at the network level means? Let us say this is the first node, this is the second node, this is N1, this is N2, receiver and transmitter, and I want to transmit my information. So, whatever information is to be transmitted, first a communication link has to be set up between the transmitter and receiver. Let us say there is a line of sight exists between the transmitter and receiver. Then how the information will be transmitted? It is not like that it is having this 1011 information. This is the information you want to transmit and it will going to travel in the same way. Packets will be formed, and if you add header and trail information with the packet, it will be converted to frames. Frames can also be transmitted. Actually, the frames will be transmitted. Packet is just for your knowledge that it does not contain the overall information, that what will be the source address, what will be the destination address, and everything about this CRC, that is the cyclic redundancy check. It will not going to consider that thing, it will going to consider only these information. So, these packets will be formed. So, whenever we are providing a security, so that these packets which will be formed or frames which will be formed, it has to be delivered at the receiver side without any issue. Second one is next is TCP/IP protocol suite and IPSEC. So, there is a connection between TCP/IP protocol suite and IPSEC, because in case of earlier we know that OSI model, ISO has designed a model, that is OSI model, which is having 7 different layers: physical layer, data link layer, data link layer, network, transport, session, presentation and application. These are the 5 layers which constitutes this OSI model. ISO OSI model will be using these 7 layers. So, to reduce this number of layers, and we do not want to cut down this information that has been transferred, we have another particular model is designed, that is known as transmission control protocol, TCP/IP model, which is using 5 layers. So, your 7 layers will be reduced to 5 layers, which will reduce the number of hops which has to be considered for transmission from one layer to another layer. So, you can see that this is the underlying physical networks. Underlying physical networks means the basic information from where the frame has been formed, and the communication link has to be set up between the transmitter and receiver. So, these are covered under this underlying physical network. This is IP, this is Internet protocol, which is using this IPSEC, is designed to provide security at the network layer. Then UDP, TCP or SCTP is there, that is user datagram protocol. TCP is transmission control protocol, and this is streamline control transmission protocol. That is 3 types of protocols that are used in TCP/IP protocol suite. Then this is application. What is application? Application means these are the different applications which are being accomplished at this layered architecture. Let us say I want to take a printout from a particular printer, then a particular application can be used. I want to send an email, then file transfer protocol or simple mail transfer protocol, then there is one application that is Telnet, there is one application that is X.25. So, these are some of the applications, there are many more, some of the applications which are used at the application layer. This layer is common in both TCP IP model and this layer is common in OSI model also. So, this is the 7th layer. So, next is transport mode in action. Transport mode in action means this is host A, this is host B, it will going to transfer the information from host A to host B. This is the transport layer, you can see this is the main information from the previous layer and header will be added. At the IPSEC layer, you can see that this particular information will act as an information for, means header plus this data will act as an information at the IPSEC layer, then header will be added and trail bits will be added. At the next layer, this whole data will act as a text here and header will be added at this network layer. So, this is the basic idea behind this transport IPSC layer and network layer. So, this data has to be used transmitted at the host side. Now, next one is at host B, which is using this type of information. This is using this network layer, IPSEC layer, that is Internet Protocol security layer, than the transport layer. So, these three layers are common here both. You can see that the reverse operation will be accomplished at the from the transmitter side. So, whatever information is there, it will be reduced to here, it will be added and here it will be reduced. So, this is the basic operation, this is the physical layer operation. Now, next one is tunnel mode in action. First, in the first case it is transport mode, next one is tunnel mode in action. In case of this tunnel mode, this is host A and this is host B and this is router, this is nothing, it is a router, this is again it is a router, and between this, in between this router, this area will act as a tunnel. Tunneling operation is basically used in ATM, that is the asynchronous transfer mode, where the information will be transferred using VP and VC, virtual path and virtual channel. In that case, this tunneling operation will be used. So, this is host A, this is host B. The data will be transferred over from here, it will be transferred using this router, then it will be transferred with this tunnel and through this router, and it will be delivered at this host only. So, there are three different layers are there. First one is network layer, second is IPSEC and this one is network layer, which will going to deliver the message at these particular steps. So, this is the tunnel mode in action. So, you can say that in between this there is a routing, routers are there, routers are installed. So, what is the basic disadvantage using routers? First thing, there is no direct line of sight exist between host A and host B. Secondly, you have to insert the address of particular routers. Let us say it is router A, this is router B, each is having own physical address that has to be inserted with the actual address of the particular user. So, let us say this is the data, this is source address, this is destination address, and here the router information has to be inserted. Okay. Then here it will be a router B, where again there will be a source address, there will be a destination address, and it should have a data. Router data is not required because the next one is the destination only, but whatever message is there, it will require a router address of this router only. So, this will basically going to increase the confusion or the complexity of the header information. Next is authentication header protocol in transport mode. So, data used in calculation of authentication data, except those fields in IP header changing during transmission. So, you can see over here that this is the IP header, that is Internet Protocol header. It is having using this transport layer payload, and padding will be used. Now, padding is what? Padding is basically whenever there is shortage of number of bits are there and you want to increase the number of bits for the purpose of transmission, then padding will be inserted at the end of particular frame. So, it is of 8 bits, that is the next header. Then payload length is there, which is again it is of 8 bits. Then 16 bits of information, which is reserved for the future use, because if you want to use this particular packet for any required message for any particular type of data, then it will be reduced for the future purpose. Next one is security parameter index. Security parameter index is nothing, it is related to the security part. If because we are talking about internet security, we have talked about network security, because network establishment is very easy part. When we talk about security point of view, when we concerned about security, that yes, that particular message has not to be delivered to any other user, then in that situation this security plays a very important role. Next one is sequence number, and then there is authentication data, which uses this digest or variable length data. So, that is the authentication header protocol, which is used in transport mode. Next is SSL and TLS. SSL or TLS, what are these? So, two protocols are dominant today for providing security at the transport layer. First one is secure sockets layer protocol, and another is transport layer security protocol, TLS and SSL, that is secure socket layer, and another is transport layer security. The later one, that is the transport layer security, is actually an IETF version of the former one. So, basically this is again the same diagram, which is the part of TCP IP protocol. First one is the underlying physical network, which is using this communication link that has been set up between the transmitter and receiver. It can be connection oriented, it can be connectionless. So, it will be an underlying physical network, which will going to deliver a particular message. Then there will be an IP address, you can say, or the IP information. Next is TCP. So, SSL and TLS is designed to provide security at the transport layer basically. So, at the TCP, because IPSEC here we are providing another security, that is IPSEC, whereas in case of TCP we are providing this SSL and TLS. These are designed to provide the security at these points only. So, this above this there will be an application layer, which will be responsible for the various applications that has been used, like I have told you, like Telnet, FTP, FTP is there, then X.25, SMTP. So, these are the different applications that will be accomplished using this application layer, 7th layer, that is very next to the host at the transmitter side and close to the host at the receiver side also. Next is SSL cipher suite list. First one is cipher suite, like this is SSL null with null operation, this is for MD5, this is SHA, this is MD5 again. So, these are the different cipher suite. Then this is key exchange algorithm. So, there are different algorithms are there. If you want to exchange the key, then key exchange algorithms are there, like first one is the null operation, then RSAs are there, then DHNN again. So, these are the different key exchange algorithms. Then encryption algorithm is also there, like the null algorithm is there, then RC for 128, IDEA CBC algorithm is there, RC for 128 algorithm is there, DES CBC. So, these are the different encryption algorithms that are used over here. Next is hash algorithms. Hash algorithms are denoted by this SHA, MD5, null. So, these are the different SSL cipher suite list. So, corresponding to each one, you can verify this one, like you can see this is SSL RSA with RC4. So, what does it mean? It means that key exchange algorithm will be RSA, then encryption algorithm will be RC4 128 and SHA will be the hash algorithm. So, this will be encoded like using this list. Next is this is continued one, this is SSL cipher suite list second. This is again showing that this is the key exchange algorithm, that is DHE RSA. Then this is using this encryption algorithm, that is DES CBC, and this is SHA, that is the hash algorithm which is using over here. So, this is the SSL cipher text list suite list next version. Now, next one very important one, that is creation of cryptographic secrets in SSL. How we are creating the cryptography secrets in SSL, SSL and TLS. So, these two are used to provide the security at the transport layer. So, in this case if you can see that this is key exchange handshaking. First we will begin with this one. Then there are three things are there. First one is random number, this is pre-master secret and this is random number again. This is client and server. You can say that this is the receiver, this is the transmitter, because server will going to provide the services to the client. There are more than one clients are also there. So, this is denoted by random number, then this there is pre-master secret. Then there is a complex algorithm using SHA1 and MD5 which is using this some constants. So, there is a master secret is also there, then a complex algorithm using SHA1 and MD5 which is using some constants. So, you can see that there are 6 different keys are there and 2 vectors, like first one is the client authentication key, second is server authentication key, another is client encryption key, server encryption key, client initiation vector and server initiation vector. So, these are the 4 are the keys and 2 are the vectors, both are related to 6 different things are related to, 3 are related to client, 3 are related to server only. So, this is key exchange handshaking. Whenever we want to handshake, there are 3 different words: key exchange handshaking. Handshaking means in communication you want to transmit the information for a very short time, you want to handshake, you have to handshake. Whenever you greet someone, you first thing is that you have to exchange, you have to handshake. So, in that same manner handshaking means a communication link has been set up between the transmitter and receiver and they are able to transmit or receive the information. Key exchange means whenever we are talking about the security, then a secure key is required which will be delivered using this, it can be symmetric key, it can be asymmetric key. So, various algorithms are required, like this one is complex algorithm using SHA1, this is complex algorithm SHA1 and MD5. So, both the things are there. Next is for SSL protocols, there are different protocols are there. This is transport layer, again this is record protocol. Record protocol is using three different protocols. This is handshake protocol. So, handshake protocol is same. So, transmit of for the purpose of communication, for the purpose of exchange of information, you have to handshake. So, that is a protocol. For handshaking also there is some criteria that you have to consider. So, that is the handshake operation. Next is change cipher spec protocol. Next third one is the alert protocol. So, these 3 protocols will going to constitute this record protocol and these are covered under SSL, which will going to provide the security to the transport layer. So, these will going to provide the security to this transport layer and this is being used by this application layer only. So, this is the 4 SSL protocols. Next is handshake protocol. This is showing that how the step by step operation will be performed in handshake protocol. So, in this one, this is the client, this is the server and information has to be exchanged between client and server. This is phase 1, that is establishing the security capabilities. Phase 2 is initiated by this one, that is the server authentication and exchange key. third phase is being initiated by this client, that is client authentication and key exchange. This is phase 4, that is finalizing the handshake protocol. So, before this handshaking which has been done established between the transmitter and receiver, it has to follow some protocol. So, these protocols are, first one, before you are going to, you want to access something, you require a acknowledgement or you want a authentication confirmation from that particular device, that yes, particular receiver you want to access is having some authentication. So, this is demonstrated in this particular diagram, like establishing the security capabilities. So, it will going to ask the server that please ensure that a security capabilities are established. In case of phase 2, it will going to send the server authentication and key exchange will take place. Third phase, after the server is authenticated and the key is exchanged, at the third phase the client authentication and key exchange is being performed in the same manner, but by the client only. And the final step is the finalizing the handshaking protocol. Protocol means a set of rules that has been agreed by both the transmitter and receiver. So, that is why it is the same case, that by after passing through 3 different phases, at the fourth phase we have finalized the handshake protocol. Next one is PGP. PGP is one of the protocols to provide security at the application layer, that is pretty good privacy. PGP means pretty good privacy. It is designed to create authenticated and confidential emails. So, here we have learnt about IPSEC, here we have learned about TLS or SSL that is being provided, and here at the application layer it will going to provide this security, that is the pretty good privacy, that is PGP, which is designed to provide the security at the application layer. Last topic of this today's lecture is firewalls. So, all the previous security measures cannot prevent Eve from sending a harmful message to a system. Now, what is Eve? Eve is a third party like Alice and Bob. So, to control the access to a system, we need firewalls. A firewall is a device installed between the internal network of an organization and the rest of the internet. So, you can see that a wall has been created which is of security wall, which will going to separate this global internet with the internal network. Internal network can be a LAN, it can be a WAN, it can be a MAN, but mostly we are concerning about LAN. So, it is designed to forward some packets and filter is not forwarded, only packets are forwarded to others. So, that is the main concept of firewall. So, this is the packet firewall. In this diagram you can see that how the packets will be transmitted using this firewall. So, this is the interface, this is the interface 1 to 1112, then this is source IP address, that is the source internet protocol address, this is source port, that is having this value only, this is destination IP address, this is destination port. So, this is the destination IP address. Now, IP address, this is IPv4 address. How I am going to find out that this is IPv4 address? Because it will going to support 32 bit of information. In case of IPv6, it will going to support 128 bit of address. So, this 32 bit will be demonstrated by this one and it will be separated by decimal points, and this is the destination port, that is denoted by this 23. So, you can find out this how this packet filter firewall will work. It will going to separate the information from the global internet with the internal internet. So, these are the interfaces, and this is source IP address, source port, destination IP address, destination port. Next one is the proxy firewall. In this proxy firewall, you can see that this is the global internet, this is proxy firewall, and this is using this hypertext transfer protocol HTTP packets. All these are collected over here. This is HTTP packets. This will going to provide this service to this HTTP proxy, and this is HTTP server. These are the accepted packets which are accepted without any error with the use of security, and these are the errors which are checked at the proxy firewall. So, basically this is the use of this proxy firewall. So, in this firewall, this is over all the above security that are provided at the TCP layer, at the transport layer, at the IP layer, at the application layer. We have learnt about firewall, which will going to separate the global internet with the internal internet, and it is of two types. First one is the packet firewall, another is the proxy firewall. In both the cases, the security is quite high as compared to the previous cases. So, these are the references that you can consider for this particular topic for the internet security. Thank you.